In this video, I'm going to show you how to graph the quadratic when it's written in Vertex form. So first of all, to identify an equation that's written in Vertex form, we look at this. This is the general form we write it in. So we have y equals a times x minus h quantity squared plus k. Now this looks very similar to an absolute value equation, where this would be replaced with absolute value bars instead of parentheses squared. And they have similar properties. Well, the first thing we're going to look at when we have vertex form is, well, what's the vertex? The nice thing about this particular form, since it's named vertex form, it tells us automatically what our vertex is. Well, our vertex is the point hk. Well, you could be wondering, why don't I write minus h? Well, similar to that of an absolute value equation, it's going to be the opposite of whatever number is written here. So minus h is h. And I'll show you an example here in just a minute. Now the other thing we need to know is called the axis of symmetry. And that's what this abbreviation stands for. Our axis of symmetry is the line that cuts our parabola, which that's what shape this is going to make, cuts our parabola in two even pieces that when we fold it over is going to lay on top of each other. Well, our axis of symmetry is the vertical line x equals h. So the x coordinate of my vertex. So let's use this information to graph. So here's what I'm going to do. I'm going to graph y equals negative 2 times x plus 1 squared plus 3. So I instantly know that it is written in vertex form because it's a times x minus h quantity squared plus k. So I'm going to start out by finding my vertex, and that's generally how we always start our graphing, is find the vertex, also known as the turning point. So let's see, my h value in this case is going to be negative 1, it's the opposite of what's here, and my k value is going to be 3. Well then that makes my axis of symmetry be the vertical line x equals negative 1. So I'm going to start out by graphing those two things. So let's see, negative 1, 1, 2, 3. And then I'm going to draw my axis of symmetry. And just a reminder, this is the line x equals negative 1. So I've got my vertex, I've got my axis of symmetry. Now what we're going to do is we're going to choose 2 points, 2 x values on the right side of my axis. And then I'm going to use those values to find the corresponding y's in order to make some points. So let's start out with 0. 0 is over here, it's on the right side of my axis, and I also know 1 is on the right side. See, 1's over here. So let's start out by plugging 0 into this function. So negative 2 times 0 plus 1 squared plus 3. Now, a common mistake, you could be thinking, well, there's parentheses, I need to distribute. Can't do that here. In this case, there's parentheses squared, so we have to follow order of operations. So the first thing I need to do is I need to do 0 plus 1. So I have negative 2 times 1 squared plus 3. Well then, 1 squared times negative 2 is negative 2, plus 3 is 1. So that gives me the ordered pair 0, 1. And I'm going to go ahead and plot that. Then I'm going to go ahead and follow the same procedure and plug in 1. So this would be 1 plus 1 squared plus 3. So let's see, that would give me negative 2 times 2 squared plus 3. So that would be 4 times negative 2 gives me negative 8 plus 3 is negative 5. Let me scoot this out of the way. So what I'm going to do now is I'm going to plot this too. So I have 1, negative 5. So let's see. 1, 1, 2, 3, 4, 5. Now from here I don't need to do any more calculations. And you could be wondering, well, don't you need to find points for the left side as well? Well, this is where the axis of symmetry comes in nicely. Since this is a symmetrical shape, a parabola, I can reflect these points across my axis of symmetry And those will also be on the parabola. So for this one, it's 1 away from the axis. So that makes my other point be 1 away from the axis. This one is 1, 2 away from the axis. So I go 1, 2, and there's my other point. So now I have all the information I need. I have points on the left, points on the right, and then I'm going to go ahead and connect them using as smooth a curve as I can get. And I need to apologize in advance. This curve will probably be a little rough. Oh, we're getting there, getting there, getting there. And there is the parabola. And it opens down because we have the negative, so we can know that automatically. Since this is a negative 2 on the front, this is going to open down. Now the last thing that we're going to look at is minimum and maximum. Well, in this particular parabola, since I'm opening down, I'm going to have a maximum, a highest point on the graph, because this goes down and down forever, so I'm never going to have a minimum, but I do have a highest point. Now my maximum, well, conveniently, is located at the vertex, and the vertex will always be either the maximum or the minimum of a particular parabola. So our maximum, in this case, is located at the point -1, 3. And generally, we just like to say our maximum value of the graph is 3. So generally, you don't really need to include the point. We know it's the vertex, but we say we have a maximum function value at 3. So that's how you graph a parabola given in vertex form. Find the vertex, axis of symmetry, go ahead and draw them, pick 2 x coordinates on the right, plug them in, then reflect across the axis of symmetry, connect them, make as smooth a curve as possible. As you can see, mine's not that smooth. Hopefully you can make one a little smoother on paper. And then determine your minimum and maximum. And that might be a question extra after graphing.